What is the carrier signal? The specific frequency at which the carrier signal runs is called the carrier frequency and is measured in hertz. The modulation of the carrier signal enables information, such as voice or data traffic, to be integrated into the carrier signal. The carrier signal thus carries the voice or data information using modulation technologies. The type of modulation used in digital communication systems depends upon whether the underlying carrier signal is analog or digital. For example, in digital radio or microwave communication, some form of digital analog modulation, such as frequency shift keying, is used to impose the digital information on the analog carrier wave. On the other hand, in Ethernet networking, a digital-digital encoding scheme, called Manchester coding, is used to enable the digital signal to carry binary ones and zeros. So, what is a carrier wave? It's a pure wave of constant frequency. By itself, it doesn't carry much information, such as voice or data. To include voice or data, we need to impose another wave on the top of the carrier, an input signal. This process of imposing an input signal onto a carrier wave is called modulation. In other words, modulation is the process of changing the shape of the carrier wave to somehow encode the information we want to transmit, voice or data. Any wave has three basic properties. Amplitude, which is the height of the wave. Frequency, which is the number of waves per unit of time. And phase, which is the constant that tells us the value of the sine function when t equals 0 and x equals 0. We can tweak the height of the carrier. If we create an input signal whose height varies with the loudness of our voice, and we add this to the carrier, then the carrier's amplitude will change, corresponding to the input signal that's being fed into it. This is called amplitude modulation, or AM. Suppose that we change the frequency of an input signal. If we add this input signal to the pure carrier wave, we thereby change the frequency of the carrier wave. In that way, we can use changes in frequency to carry our voice or data information. This is called frequency modulation, or FM. We can also combine these two strategies to create a third scheme of some kind. Any strategy that combines in some systematic fashion an input signal with a carrier wave to encode voice or other kind of information is called a modulation scheme. Modulation schemes can be analog or digital. An analog modulation scheme has an input wave that varies continuously, like a sine wave. A digital modulation scheme is a little more complicated. Voice is sampled at some rate and then compressed and turned into a bit stream, a stream of zeros and ones. And this, in turn, is created into a particular type of wave, which is then superimposed on the carrier. Why have carriers and modulation at all? Why don't we use that input signal directly? The input signal, after all, is carrying all the information we're interested in, not the carrier. And it only occupies a few kilohertz in bandwidth. So why don't we use it directly? First of all, that kind of information could be carried by very low frequency electromagnetic waves, and there's a problem with this. In order to transmit those very low frequencies, we're going to need quite a bit of amplification in order to boost the power, because they themselves don't have that much power. And you're going to need some fairly large antenna in order to transmit all of this. So, in order to make it cheap and convenient, and use as low power to carry as much information as possible, we use this carrier system, with modulated carriers. If you want to learn more about networking concepts and definitions, don't forget to press the subscribe button. To be notified when our channel releases another video, click also on the bell icon. And don't forget to visit our website, networkencyclopedia.com.